38 is very similar to the one I worked earlier with the double angle, except this one is asking for my half angle formulas. So I'm looking for the cosine, the sine, and the tangent half angles. Alright, so remember that the important thing here is the quadrant of the half angle determines the sine that I'm looking for. So if they give me that the angle is between 180 and 270, the half angle is going to be between 90 and 135, which is actually in quadrant 2. Alright, so that's going to determine my sines. Now, if I'm looking for the sine of x over 2, notice that in these formulas right here, I have to know the cosine of x. Well, they gave me the cosine of x. If they hadn't given me the cosine of x, drop a triangle and find out what the cosine of x is based on the information they've given you. They've already given me all that, so all I'm doing is plugging it in. Now, the half angle, like I said, is coming out of the quadrant 2, and we know that the sine in quadrant 2 is positive. So I'm using the positive square root of 1 minus cosine of x, which is negative 4 over 5, all over 2. Alright, and I'm going to do just like I did before. The easiest way to simplify this is to multiply every term by the common denominator. In this case, my common denominator is 5, so I'm going to multiply all 3 terms by 5. So I've got 5 plus, because I've got a double negative there, and then when I multiply that by 5, those 5's are going to cancel, and that's going to leave me with 4 all over 10. Alright, so this is going to equal the square root of 9 over the square root of 10, and I just went ahead and split it up because I can do that based on the quotient rule. Alright, so this is going to be the 3 over the square root of 10, and really in this course, if you want to rationalize the denominator, you multiply the top and the bottom by your square root of whatever's on the bottom, so that's going to simplify to 3 times the square root of 10 over 10. Alright, so that's the half angle for sine. Half angle for cosine, quadrant 2, it's going to be negative because the cosine is negative in quadrant 2, so I'm using the negative square root of 1 plus cosine, which is still negative 4 over 5 all over 2. I'm doing the same thing I did above. I'm going to multiply everything by 5, so that's going to give me 5 minus 4 all over 10, which is going to be the square root of 1 over the square root of 10. And if I multiply by the square root of 10 again, I get the square root of 10 all over 10, and that was negative. Okay? Tangent, half angle of tangent. I'm not going to go through that formula because then I would have to find the sine of x. I already know what the sine, the half angle of sine is, the half angle of cosine is. So let's just plug it in. We've got we found the half angle of sine, which was 3 times the square root of 10 over 10. And really I could use the unsimplified version and it would make it a lot easier. And that is negative square root of 10 over 10. When I flip this and multiply, that all goes to negative 3. Okay? Alright, the next thing we're going to do is we're going to use the double angle or the half angle to prove the identity. And remember, when we're proving an identity, we're just showing that the left side equals the right side or vice versa. Okay? If I'm looking at 74 here, I've got the sine of 8x equals 2 times the sine of x cosine of x. X in this case would be 4x. Alright, so let's just rewrite this. Isn't this the same thing as sine of 2 times 4x? Yeah, Yes, because 2 times 4x is 8x. So here's my x value. This is my double angle. So 2 times x in this case is 4x. And when I plug 4x into my formula right here, I get 2 times the sine of 4x times the cosine of 4x. And that's what I was trying to show. So that's all I need to do for that one. Okay. I've got one more here, and I'm going to go back to our basics. And I could certainly take this and go, well, this is my double angle, and I'm going to plug that in and make that 2 times the sine of x times the cosine of x. Same thing here, and then clean all that up. I'm actually going to go back to what I learned originally and think I'm going to rewrite all this in terms of sine and cosine and see if that takes me anywhere. Alright, so I've got 1 plus 1/2 times the secant of x is the reciprocal of the cosine of x. The cosecant of x is the reciprocal of the sine of x. So far I've got 1 plus 1 over 2 times the cosine of x times the sine of x. Alright, now at this point I would go ahead and get a common denominator and put these two fractions together. My common denominator is going to be 2 times the cosine of x times the sine of x, and I need that over here. So when I multiply the top and the bottom of 1 over 1 times that, I get 2 times the cosine of x times the sine of x over 2 times the cosine of x times the sine of x. That's just an equivalent fraction. Plus, when I multiply, I don't need anything over here because I've already got my common denominator, so I'm just leaving that the same. Alright, and so when I've got my common denominator, I can add my numerator. So I've got 1 plus 2 times the cosine of x times the sine of x, and I just rewrote that. It doesn't matter, the order doesn't matter, all over my common denominator. Alright, so where am I headed now? I've got 1 plus 2 times the cosine of x times the sine of x all over 2 times the cosine of x times the sine of x. And I already know what this is. That is that. So I can rewrite that as the sine of 2x. That is the same thing. Okay? And like I said at the very beginning, I could have gone the other way with it. I took this, rewrote it, and then went from here to here. I could have started here and gone from here to here and ended up with the same thing.